React Native developers, in this video, we're going to implement the Tinder swiping example. So first, let me show you how it looks like. So I can drag the card around. And according to its position on the x-axis, it rotates slightly. And you see the opacity of the like and the nope changes depending on the x position. I can also translate on the y-axis. I release the card and it can either go back to the top or swipe to the left or to the right. And you have also some buttons at the bottom that you can use to do this command imperatively. I'm pretty excited about this video for 3 reasons. First, behind this example, which is very specific to the Tinder swipe, we're gonna use 2 very generic recipes that you can use in most of your code. In fact, in the React Native Fashion app, we use this recipe a couple of times in a couple of different components to implement, for instance, a swipeable row, to implement the complex layout of the cart checkout. And what is this recipe? It's simply to have a pan gesture handler. When we start the gesture, we remember the position, so we keep an offset value. When the gesture is active, we translate the value, so whatever is the value of the pan gesture handler plus the offset value. And when we release, we decide on where to snap, right? So here, if I go to the left or to the right, depending on the velocity of the gesture and the position, we decide where to snap. For this, we use a function from Redash, which is super simple. What the function does is that it calculates, depending on the position and the velocity, where would be the position in 200 milliseconds. And based on that, it selects the closest point, and that's where we're going to spring. That's the behavior you could configure, right? The 200 milliseconds is something somewhat arbitrary, but it works very well for us. And so this recipe, we use it everywhere. And then there is also another recipe which is pretty generic, is that, so we have this gesture that drives the animation, but we can also execute the gesture imperatively by clicking a button. This is also a very common use case. I have in mind the Spotify player, right? Where you can swipe up and down the player, but you can also do it via the press of a button. And that's something we had to learn in Reanimated 1, and now we have to learn it in Reanimated 2, which leads me to the second reason I'm so excited about this video, is that we're going to see how much simpler these things can be done in Reanimated 2. So that's very cool. Now, the last reason that I'm excited is that beyond these recipes, there are some things we're going to do which are specific to the Tinder example, which we might only do in this particular example, and we might not be able to take away somewhere else, but who knows? The first thing is, you see, because we have this rotation when we move on the x-axis, is we need to calculate the minimum distance to swipe to the left or to the right where we hide the card. So what is the width of the card when it's tilted to its maximum position, and we're going to use just some fun trigonometry to do this. Another thing which I think is somewhat specific to this swipe card example is that we have a spring configuration, and you see here it's nicely, it bounces, really this nice physics behavior. It feels great, feels very nice. But when we swipe to the left or to the right, we execute a side effect. We say, okay, it's a like or a dislike. We want to, once the card is not visible to the user anymore, we want to execute this side effect as soon as possible. We don't want to wait to have this small oscillation, which gives a nice effect because we cannot see the card anyways. So we're going to change the configuration of the spring depending on where we snap. And namely, we're going to change 2 parameters, which are the displacement threshold and the speed displacement threshold. So when do we decide that the animation is over? And so if we swipe to the left or to the right, even if the speed or the translation is high, we want the animation to stop, since we cannot see it anyways, so we can execute the side effect as soon as possible. And then we have this nice scale animation based from the Tinder app. So depending on if the card goes to the left or to the right, the card below gets closer. So it feels like you see a new card on the stack is appearing, so which is a very nice animation. And so we're gonna build it too. So we're gonna do this in 3 steps. First, again, pan gesture handler. On start, we keep the offset. On active, we translate. On end, we spring to a position. This is our bread and butter, very generic recipe. Then we're gonna add the scale animation, which I just mentioned. And then we're gonna add the imperative commands to our component. So we can also swipe left and swipe right on the press of a button. We have our boilerplate here. We store the profiles into a state. When we swipe on the left or the right, we remove one profile, the top profile from the state. And so here we loop, and we have our swipeable component where we're going to implement the swipe gesture. So you know the drill. We wrap it into a pan gesture handler. First and unique child of a pan gesture handler is an animated view. So let's do it. Pan gesture handler, animated view, and the component that is wrapped into it. So here I'm going to use, to keep the layout, absolute field positioning. And we need to create our pan gesture handler. So on gesture event. So on gesture event is use animated gesture handler. And we know on start, on active, on end, we need to implement these 3 events. And we know that we need to translate on the X and Y axis. So I'm going to create a translate X and translate Y animation value. So translate X and translate Y. So let me import these things. Animated from reanimated to. Okay. On start, so we know that we need to keep the X and Y value as an offset. So here, let me import use animated gesture handler. Okay, so if we go to the type signature, we have the type of the context as a second generic property, and the first one is the type of gesture. So here it's the pan gesture handler, pan gesture handler event. So here we use the default parameter, and then we have our context, which is offset. So I can write it here. Type offset equals X. And we keep these values into an offset. So in case, so to make the gesture interruptible, we want to remember where we are when we start the gesture again. So if, you know, the card is moving somewhere, and while it's still moving, I start the gesture again, I don't want to start again to 0, for instance. I want to start to the position where I was. So on start, we store the values in the context. So we have context.x equals translate.value, and same for y. Now we can translate on active. So on active, we get translation X, translation Y, and the context. So the context, again, is a state. We can make our gesture stateful by storing values across the gesture events in the context that we can get back here, for instance. So we can write, for instance, translate x.value equals translation x plus context.x, and same for y. And you see, I love how so I use the timeline plugin. So I did something on X, and it automatically inferred what I was doing on the Y-axis. So this was auto-completed automatically, so that was pretty fun. So let's see if this moves along nicely. So I'm going to pass these 2 values as a property of profile, so we can translate it. So I'm going to do, Again, So now I can add it to the properties quickly. Translate X is an animated share value of number, and same for Y. So this one here, this container of the card is going to become an animated style. So animated view. And so we can create the style using use animated style. Transform. So here I can use translate X, translate Y. And we have translate X equals translate X dot value, and translate Y equals translate Y dot value. So let's have a look. So you see here it moves around nicely, but of course, when I release, nothing happens. So we need to snap somewhere, either back or to the left or to the right. So let's write on end. And here we're going to use the velocity of the finger to know where we need to snap, and also for the spring configuration. So yeah, velocity X, velocity Y, perfect. So what are our snap points? We first need to calculate the distance between, so because the card is tilted, to swipe to the left or to the right, it's not the width of the card, but the width of the tilted card. So let me see if I can show you a sketch here quickly. So this is the card. So and it has a width and a height, but we rotate it by a certain value. Let's say, for instance, 30 degrees or minus 30, it doesn't matter. And what we want, so let me do, is the width of this rectangle that contains the tilted card. And we can do it by using some simple trigonometry. So we would have, so we can calculate this width plus this width using these two right triangles. And we know that so this angle is 30 degrees. So we know here sinus of 30 degrees. I think sinus is opposite on hypotenuse. So that would be cosinus of A equals the height. No, sorry, opposite. So the value we're looking for, let's call it x1, divided by the height. And on this one, we can take this angle, which would be, because we know this value here, so this one is also 30 degrees, so we would have cos, no, sorry, this one is sinus, and this one is cosinus of alpha, is x2 divided by width. And so that gives us the width that we want is x1 plus x2, so that would be x1 is h times sinus alpha, so height times sinus alpha. We just maybe make, I actually have a video where I go over this computation in a bit more details, and I will link it in the resources, but this is the width we are looking for. So some simple, fun trigonometry. So let me see. So we have the maximum rotation angle here. So actually, should I calculate here? I can calculate A equals, so math sinus of alpha times 8 plus math cos of alpha times width. And we have with 8 from dimensions. Okay, so that gives us our snap points. Our snap points are, so I can write it here, minus a, 0, or a, where a is the value we just calculated here. And redash, based on translate x and velocity x, redash provides us a function to know where to snap. So I'm going to use snap point from redash. So first value is translate x, velocity x, and the snap points. Again, what this function does is simply calculate the position of x depending on the velocity in 200 milliseconds, and then take the closest point to this value. So for translate y, we always go back to 0. So this one is easy. So we do with spring to 0, and we can, for good measure, pass the velocity y as parameter. For x, we go to destination. So with spring to destination, we can also pass the velocity. So you see here it snaps back nicely in position. Now when the spring finishes, so here with the callback for when the animation finishes, if it's not 0, so if we swipe left or to the right, we want to execute a side effect. We want to say, okay, the card has been liked or disliked. So if destination is different from 0, we call back. So here we are on the UI thread. We need to call back to the JavaScript thread to execute the side effect. And we render on component. And to do this, we use run on JS. We pass the function as parameter, which is on swipe. We've seen this function just here, I think. So that's this function here where we do a set state. So we just, from the UI thread, say run this function on the JavaScript thread. And you can also pass, you see, parameters. So for instance, here we could pass the destination parameter to know if we swipe left or right. Here we're not using it, we just remove the card from the state. So here it snaps back, left, and you see, perfect. So you cannot see my finger, but this is great. So what happened is that I swiped left, and then I try to, you see I'm trying to move this card and it's not moving yet, and now it's moving because it took so much time for the animation to be over and for this side effect to be executed. So this is what we're going to do, is that if the destination is not 0, we're going to change the spring config so the animation finishes super fast. And we're going to tackle 2 parameters. The first one is rest speed threshold. If the destination is 0, then we want to keep it very small. Could be 0.1, 0.01, doesn't matter. Especially since we implement the on start, the gesture is interruptible. So if it takes forever for the spring to finish, that's fine. So we can put 0.1, 0.01, doesn't matter. But then if we go to the left or to the right, we want a really big value, can put 100, for instance. And same for the rest displacement threshold. So this is for velocity, and we can do the same for the translation. So, okay, up, and you see it's pretty fast. Yeah, it's very fast. Perfect. Let's do 2 things. We want the scale animation below, and you see here also we need to animate the rotation of the card when we move left and right, and also the opacity of the like and up button. So let's do first the rotation and opacity, which we go, so if we go to profile, let's do the rotation. So we can do, it's a simple interpolation on translate X. So interpolate on translate X.value. So input range goes from when do we want the max tilde to be done? Let's say we can pick any values. Let's pick width divided by 2. Just here, you are the judge, can be minus width, can be minus width divided by 4, you decide. So 0 and width divided by 2. And then it's minus alpha. Do we import it somewhere? No, it's here, okay. Minus alpha, oops, 0 and alpha. Or is it alpha 0 minus alpha? We're going to check. And here I want an extrapolate clamp. I don't want to go outside this rotation, these values. Let me import interpolate. So it rotates nicely. I just happen to know that on the app, it's the other way around because it looks like almost like a half, like an arc. So this is how it looks like on the app. Let's do the opacity of the like and knob. So the like here button and the knob button are going to become animated views. And so we're going to have a like style and a knob style. So use animated style. We animate on opacity. So we can select this expression here. And so for the like, we go to the right. So that would be these values. No, yeah, these values, and it goes from 0 to 1. And let's do it for nope. No. So here would be minus width divided by 2, 0, and would be 1, 0. Looks great. And here we could even use width divided by 4, just to make it go to 1 a bit quicker. But that looks great. So before we do the imperative command, let's do the scale animation below. So it's interesting because so far we've animated only the card we're moving, but now we're going to animate the cards which are specifically not moving. So what we're going to do, here I'm going to create a scale animation value because it needs to be shared basically between all the cards which are not moving. So use shared value, default value is 1, right? Scale, it's not 0, it's 1. And I'm going to pass it here to the component. We have this scale value, which is used by all the cards which are not moving, but that is the value is calculated based on the card that is moving. So the card that is moving write to the scale values, and all the cards which are not moving read to the scale value. So first, let's do the writing. So on active, translate X is going to decide the scale value. So here, when the gesture is active, based on translate X, we write the scale value, so scale.value, and we interpolate it from translate X. So translate X.value, input range, let's do minus width divided by 2, 0 width divided by 2. Oops. And we know at the extremities it's 1, and in the middle, I don't know. I know it's subtle, so let's do 0.9. 0.9 might be even too big. Should be even closer to 1. I guess it's like super subtle. Extrapolate clamp. We don't want to go over these values. Let me import the proper things. We need the width. Okay. And let's see. Nothing is happening, of course, because we are not reading the value. So I'm going to pass it here. So we can add it here as a prop. Scale and oops, and add it to the transform here. So it works nicely, but I mean, it's way too big. So I'm gonna set it, but it works, right? I'm just gonna set it to something way smaller, way bigger, 9.5. And that might even also be too big. But now let's do the last part, which is the imperative command. This is the swipe, right? We translate the thing, you see the card moving, and then we execute the side effect on end. So this is the part we're gonna need to execute imperatively. So this, I'm gonna take this out into a function which we're gonna use here, but we're also gonna invoke when we press the button. And the second thing we need to do is that we need to use a hook named use imperative handle, where we can create methods that we can use from the outside. So you see how on a text input you can do dot focus or dot blur. These were done with class components, and they were method of the component, which we could invoke through the reference. The way we do this with hooks and functional components is via the use imperative handle, and then we also need to use forward ref, so we can assign the ref, get it within the component, use imperative handle. So first thing, let's refactor this into a function, and since this one is executed on the UI thread, it's going to be a worklet function. So here I'm going to invoke swipe, so we can pass some parameters just to make it stateless. So here we could write it within the component, use callback so its identity doesn't change, or we can pass all the arguments as parameter. Here I'm going to pass all the arguments as parameter. So we need to translate x, we need the destination, we need the velocity, which is going to be velocity x, and we need the callback, which is going to be on swipe. So let's create this swipe function. So here I do it outside the component, but you don't have to. And then if you do it inside the component, make sure to use callback. And then the advantage is that you don't have to pass so many parameters. So the code we need to execute, we know what it is. So here I'm using the worklet directive because we want to be able to execute it on the UI thread. So this is the code. So I get these variables as parameters. So we have translate x, animated shared value, destination, which is a number, velocity, number, and on swipe, which is a function. Up. So maybe the first thing is to check if we didn't create any regression. Did we create a regression? Doesn't look like it. Perfect. So now let's create this imperative handle. So we need the ref of the component. So we're going to use forward ref. So now we can access the ref via a second parameter here. And so the ref is of type swiper, which is the type where we're going to declare the methods which are available. So let me do this here. So we have simply, right, swipe left, swipe right. So these are the two methods, which will be methods. These are not are functions, which will be available through the ref outside the component. So swipe left, swipe right. Okay, and now we can use imperative handle to declare this swipe left, swipe right function. So first argument is the ref. And so did we import this one here? Okay. and then the object. So we have swipe left and swipe right. And so here we can do swipe, translate X. Destination is here -a. Velocity, I don't know, 25 points per second. I don't know. Is that? I don't know. And on swipe. And on the right side, it's the same, but the destination is different. It's going to be A. So here we declared our methods. Perfect. But now we need to invoke them. So that's the last step from the outside. And in order to do this, we need the ref of the top card. So I'm going to create a ref called top card. And the top card changes. So therefore, the ref we assign changes as well. But we know that it's a ref of swiper. Oops. And I think I didn't export the type here. Okay. Okay. So now, here we're going to create a ref variable. If the card is on top, we want the top card ref. If not, we assign it to null. And that way could be null, could be undefined. That way, we always reassign the ref to the top card. Okay, so now that we should have the ref properly, we need to implement the onPress here. So we do onPress top card dot current and swipe left. And same for swipe right. Let's have a look. It's the other way around. Ah, no, it's swipe right here, sorry. Okay. So swipe left, swipe right, and I can also swipe manually. Isn't that cool? The way we implemented the pan gesture handler is very generic. This is really the way we implement most gestures and animations. Hard to do also, so to offer the gestures and animations, but as well as an imperative way to run the animation, I feel is also a very common use case. And then we looked at some things which were more in the, how do you say, nitty-gritty of this particular example, which might not be useful in other example, but that was sure a lot of fun to implement it. And I hope that you enjoyed this video as well. And I'm seeing you in the next one.